So part 2/3 of 2.13. Here we go. Robert's going to read.
Previously, we looked at inverse functions and finding the inverse of a given function, including exponential and logarithmic functions, out of the form y equals b to the power of x, and y equals log of bx. Now we will look at finding inverses of exponential and logarithmic functions in general form.
All right, so our general form, if we look at the exponential, this a is our initial value, this b is our base, and then this x plus h. What does h do? This is a what kind of translation? A horizontal translation because it messes with the x. And then what is this k actually? A vertical translation. All right, and same thing in logarithmic form. So this x plus h, this h is our horizontal translation, and our k is our vertical translation. All right, and so what's an inverse? It's a what? A switch in x and y. All right, and so let's go with these guidelines here, Robert. 1, 2, and 3.
1. Switch the roles of x and y in the equation. 2. Use inverse operations to solve for y in inverse relation. 3. Write the final inverse function using correct notation.
All right, fantastic. So in example 1, we're going to find its inverse. But my step 1 is to do what? Switch x and y. And so now I end up having x is equal to 3 times 2 to the power of y plus 4, and then minus 15. And now I need to solve for y. So we can do 2 steps at once. I think we're very capable. So what can we do? Add 15 and then divide by 3. And so now I have x plus 15 over 3 is equal to 2 to the power of y plus 4. Well, what form is it in right now? Exponential. Guess what we're going to do to solve for y? Put it in log form. And so now we end up having log base what? 2, and then of what? X plus 15 over 3, and then it's equal to y plus 4. Well, how would I solve for y? I would subtract 4. All right. However, I don't want it in terms of y. What is my proper notation to say the inverse of f? It would be what? F inverse of x. All right. And so I need to subtract 4. So now I have negative 4 plus log base 2 of x plus 15 over 3. All right. All right. Cool. Let's do example 2 now. All right. So in example 2, we're finding the inverse of g. All right. And so again, what's my first step? Switch x and y. And so now I end up having x is equal to negative 3 log base 5 of x minus 4 plus 6. All right. And so now we need, oh, whoopsies. It's not x minus 4, is it? It's what? Y minus 4. So now we need to solve for what? Y. And so let's do 2 steps at once. We're good. So how do we do it? Subtract 6 and then what? Divide by negative 3. So now I end up having x and then minus 6 over negative 3 is equal to this log base 5 of y minus 4. Now, it's bad etiquette to have like a division of a negative. It's not necessarily wrong. However, an answer choice with a negative in the denominator like that will never show up. And so the way we get rid of it is we just go pum, pum, pum. And so we just distribute that negative throughout. All right, and so anyway, I don't want you to keep the negative in the denominator because if you look for a multiple choice question, will it ever be there? Never, ever. All right, and so then I have a log form. So now what do I put it in to solve for y? Exponential form. And so then I have, so now we have 5 to the power of negative x plus 6 over 3 is equal to y minus 4. All right. And so then how do I notate taking an inverse? It's not f anymore. It's actually what? It is g. And so now I'm going to notate it as g inverse of x is equal to, what do I need to do to solve for y again? Add 4. So now I have 4 plus 5 to the power of negative x plus 6 over 3. All right. All right, let's keep going. Robert, can you read example 3 for us?
Sure. Let h of x equals 3 to the power of x plus 1 minus 2, and let k of x equals h inverse of x. For what values of x does k of x equal 1?
All right, so on this one, I like to figure out what it's doing, so I like to make ordered pairs. And so k of x is equal to h inverse. And so it says k of x is equal to 1, and so I'm going to go with ordered pairs. So I'm going to say h, and I'm going to say h inverse. So this is trying to figure out when h inverse is equal to what? 1. And so is this the x of the inverse or the y of the inverse? It's the y. And so I'm going to put it as the y right there. Which means, what do I know about my h? It's the x. So if I need to solve for the x of my inverse, I can actually solve for the what of my h? My y of my h. Well, how would I solve for the y of my h? Just do what? Substitute it in. And so all I'm going to do is find h of 1. And so h of 1 is 3 to the power of 2 minus 2. So 3 squared is 9. 9 minus 2 is 7. And so then I have h of 1 is equal to 7, which means my h inverse would be 7 comma 1. And so for what x value does k of x equal 1? At x equals what? 7. All right, because an inverse is a switch in x and y. All right.